Okay, for people who are joining the live stream, this is a review of functionality for handling microcontrollers in Wolfram Language. We've looked at some of this before. This is kind of my second look at this. So where should we start? We should start at the guide page, probably.
Can I assume that you sort of remember the big point of this and everybody else that's going to have an opinion?
Yes, I think so.
Okay, good.
Okay, formatting. The word sample projects shouldn't be in the same font. That should be a different font. I mean, that should be a different, this should not be presented this way. Am I making sense?
We discussed this last time. So this is exactly the way, even for system modeler,
okay, it's not the right way to do it. It should not look like a function name, okay?
Okay, so we don't have a precedent for this, Stephen. So
I
we have to make
that. So let's get one. Okay, so Alex, could you please get Brian Van Vertlu here?
Yes, just a moment.
Thank you. Okay, and that's what how we're going to make it up.
But it is crucial that it comes on top.
That's fine. It's all good. Not a problem with that. I just want a different style. Okay. Now, why is that a different color? Microcontroller embed code. That's in the microcontroller. Okay, but this, oh, these are all in that. So why aren't these all in that different color? They should be. Am I making sense?
Yeah, I don't know.
Okay, so that's a mistake. Okay, but some of these are not. Some of these are generic.
Yes. So these are there because these are useful. Anything that comes.
I get it. These three things are all part of the microcontroller kit, and they should be in the different color. And these are all generic functions, and they should not be in the different color. I get it.
Right.
Okay. Do we have Brian here yet?
Okay. Still working on finding him.
Okay. Alternatively, find somebody from project management, please. Okay. So let's take a look at these actual functions. Oops, that's not good.
Or you can just click that on the guide page.
Yeah, but that's only giving me, that's not going to an editable version. That's okay.
It's going to be a little bit hard to edit here if you want to do that.
Yeah, I know, but why is this not showing up as that's a bug of some kind that's not showing up with a preview image there? Did you understand what I'm saying?
These are things that either Suba or Brian can answer because this is not like a normal functions. So there could be something in the workflow, build flow, that's not doing that.
Yeah, I know. That's the point that I'm making.
Okay.
Is that really the right phraseology, mu-c there? Is that what people call them?
Yeah, that's an abbreviation for microcontroller.
Okay. Again, there's a font problem there. You need to get that fixed.
Okay.
All right. Preview image, you got that?
Yes.
Okay. I would say here, by the way, turn on the LED of an Adafruit. I don't know what that, it doesn't really matter. I'm not okay. Now, what on earth is all of this?
Okay. First thing as a system, the first argument is a system, and that's the standard typesetting for.
Yeah.
Okay. Now, the second argument says the microcontroller, and this is the spec language for that. Okay. And
why isn't that an association of some kind? I mean, that naked, bizarrely nested list seems very hostile.
So the way the second argument is arranged is it has three sub-arguments. The first one is the name of the microcontroller. The next one is the input specification, and the last one is the output specification.
Why don't you make that an association? so people can see what they are.
Which one? Which one?
Well, this thing here, what I'm suggesting is that this specification...
A nested association?
It's not very nested. It's just...
No. The second argument is a list of things. So there can be multiple inputs and outputs.
Okay. So wait a minute. This is input. I thought you said this is inputs and this is outputs.
Yeah, right. So there are no inputs and we have one output.
I don't like the format of this. This is crazy. I mean,
No, we can do that. But I was just trying to understand what you're saying.
Yeah, right. So what I'm suggesting...
It's just a formatting thing. It's not...
Yeah, no, I understand. So what I'm suggesting here is that look like, type or something, and then it's the Adafruit or whatever you want to call it, microcontroller, or you might call that microcontroller, I don't know.
So those two sublists will be associations on their own in that case.
Okay, wait a minute, that's inputs, is that right?
Yeah,
yes.
inputs.
Okay, so it's a list of inputs, correct?
Yes.
So are all of them is the only decoration analog or digital?
No, that's why we enumerate them in scope. There are different types. There's digital, analog input, analog output. These are all the SPI, serial.
Okay, but I understand. But I mean, could we instead have something which says something like input 1 arrow analog, for example?
Yeah. You can look at that in the details.
No. But I'm asking the question: is the right-hand side just
a single thing? A single thing.
Yes.
No, very rarely. Or if a single thing, that's only if, like, we can say serial and the microcontroller has just one serial pin.
No. You're not understanding. Listen to what I'm saying.
Okay.
I'm saying there are inputs. We've got inputs on wires to, and I don't think they need to be strings. I think you should accept them as non-strings. Okay. For the ports of the microcontroller, right? If it has numbered ports, like a Raspberry Pi has numbered ports for GPIO, right?
Okay.
What we've done in the Raspberry Pi controller is we've just allowed integers for that, and we should do that here as well. Am I making sense?
No, I have to look at that. So
no. I'm explaining the. I'm telling you what we should do. Okay.
Okay.
I really think it would be better to have a project manager in these meetings.
So you can see here, by the way, Stephen, that what you have analog is not always just a string. It can be a list of things.
What can be a list of?
See the channel specification.
The one goes to analog. That analog can also be a list.
No, I understand. Channel specification is the name of the channel, the configuration of the channel.
So,
have you looked at how the device system works? Because that has had some of these issues as well. Have you looked at how the device...
I have looked at that. And
is this consistent with that or not?
yes, because there they have GPU. Okay, let me...
No. You're not understanding what I'm saying here. Hold on. Oh boy, isn't it lovely that those are pink down there? Another thing, somebody needs to report that as a bug.
So it's not by design?
Nope.
No, it's a bug. It's been reported.
Okay. All right. So, see here? Okay, so the way we're doing this is 4-hour output, 17-hour input. Okay?
Yeah.
Which is not quite the same, but notice that they don't have string names, right?
Yes, but we're just saying output and input.
I understand. I understand completely. These are port numbers, right? And what I'm saying is don't put them in strings. Okay?
Because sometimes we have to, because something...
I know that. I told you, put them in strings if you have to.
Okay.
Don't require them to be in strings.
All right, got it. Yeah.
Okay? I don't. Where are you saying what the names of the channels can be? No, I don't understand. Oh, I see. Configuration. Where are the configuration? Possible configurations.
Possible configurations. That's what we enumerate in scope.
That's not the right place to do it. If there is a fixed set of configurations, it should be in this details and options section.
No, but that varies from microcontroller to microcontroller. Not every microcontroller.
Okay. So are we then documenting each microcontroller separately?
Eventually, I think that's what we'll have to do.
Okay.
I don't know if we document that. I think we should have a discovery interface. So we document the discovery interface to what there is.
Well, but Roger, if there's a fixed set
but the hundreds of them, okay?
No, I understand that. But like we have for devices, I think it will be good to have separate pages for each of these, even if most of the page is boilerplate.
Okay, you might be right. There's a kind of a...
Because, this thing might get long. It might have, who knows what it might have. Right? But I don't know whether this is, I think it'd be much better to put, an Arduino Uno page, which we might already have one of, for the device framework. So let me also understand what the relationship between the device framework and this is. Do you understand my question?
Yes.
So the device framework is primarily focused on what I was going to say.
Data acquisition.
Data acquisition. Yes, data acquisition. And that means that can run at a fairly slow pace.
Yes. So this is mostly about downloading stuff to run on the microcontroller itself.
Correct.
Code running on the microcontroller.
That's all that it's about.
Let me just understand the three kinds of things that we're dealing with here. Okay. So we've also got System Modeler and that whole set of things. Somebody is asking on the live stream about, is SPICE still a thing these days? I would assume that the system model stuff is what is related to that. Is that correct?
Yeah. So System Modeler covers analog electronics and many other domains. So you can have multi-domain modeling. So System Modeler is the analog of SPICE, where you sort of simulate the system in question.
Okay. So just so I understand, if I browse here, what is the relationship? So we got three different things. We got the device framework, we've got the microcontroller embedding system.
We show that. So we use all three frameworks. If you bring up some of the other documentation, I can show you the V model of system development, and then we can sort of place where they all fit in.
And by the way, I assume that we also have workflows related to this stuff in the workflow documentation. Is that true?
No.
We're going to, yes?
No, we might, but it's we reused the workflow framework to give these projects, and so those projects are like workflows.
I see. Okay. So there aren't generic workflows; there are just specific projects. Is that correct?
Right. And that's a great way to learn. By the way.
Okay. So this is our analog of something like SPICE, right?
Right.
That we can then compute from this.
Right. So typically,
okay.
Yeah.
So I should probably look at those projects there. Hold on.
No, yeah.
Okay.
All the workflows are broken. That's why you saw that pinked out.
No, I'm aware, but these aren't workflows. So am I looking at workflows or am I looking at something different? Do you understand what I'm asking? You said there are projects which are on the guide page, right?
Yeah. Yes. Go back to the guide page.
Right.
Those.
Okay.
See, but all the workflows are broken.
Okay, so show me how to get to this in DocuTools and the source. Okay? That's what you need to be able to tell me.
It's going to be hard, but we can do it.
This is
It doesn't live in the. It's done as a packlet. You know what I'm saying?
But isn't that accessible from the? Okay.
No,
right.
it's not.
Can you just send me that as a notebook, please? One of those projects, or alternatively, you can share your screen, Suba.
Oh, all right. Or what I can do is I can get you to download the beta version, and.
I don't think we want something that ornate. Just send me the notebook, please.
Okay.
Either that or share your screen. Okay, let's see. I think Brady just joined. Is that correct?
That is correct.
Okay, so you're standing in here for Brian because we need to communicate some things about documentation issues. So this is a guide page for this microcontroller kit, which relates to a bunch of functions that are the kit context, the microcontroller kit context. For some reason, this function, which is in the microcontroller kit context, isn't showing up in this teal color here.
Yeah. Okay.
Okay?
Yep.
That's the first point. The second point is that this page, which is a link to a workflow guide page, right?
Yeah, I saw that.
Okay, so that needs a different styling.
Okay.
Making sense?
Yep.
So that will need to go through Jeremy and get a style invented for that. And my feeling is that that should be something which is more like, I mean, it really shouldn't look anything like any of these.
Mm-hmm.
Am I making sense? It should be more like a button of some kind. And
Yep.
it absolutely shouldn't look like it's the same, same kind of link style as this.
Gotcha.
Make sense?
Yep.
So I just sent you that one.
I got
email.
it. Okay, so this is that workflow. So now, did DQA have the?
No, because this is in the pack list. After this they have to look at
But
it.
DQA hasn't read this. So if I
No.
notice, okay, all right, fine. So what is this? This is a link. Why is there a brackets link? I don't quite understand that. Why isn't that just a link from the, the name here?
It's horrible when we do hyperlinks that way. It continues everything.
What do you mean?
It's all the text that follow will then be in the hyperlink style.
Well, that's just a bug. So
Why? Yeah. Okay.
Brady, that's for you.
Yep.
Figure that out. Okay. Okay. So, I mean, and again, the formatting of this is less than perfect, right? If this is what it's going to look like in the final thing, I think if this is, if you're saying this is the Pulolu, whatever it is, thing, obviously there should be a colon at the end of it to indicate that what follows the thing is what follows there.
Okay.
Okay. Can whoever's typing in our ears, please?
Oh, that might be me. Sorry.
Thank you. Okay, so now what's this? Is that an additional item which isn't pictured here?
Yeah. So that is a note.
Okay, but that's a note not specific to the power supply, right?
No.
Okay, so that needs to be reformatted so that it's clear that that's a note that is, I mean, I would do this parts list. First of all, it should have less space between these things. I wouldn't bother to have these separated lines. Am I making sense?
Okay. Then no separate. Okay.
Right. Brady, are you also being able to take notes here?
I'm taking notes.
Okay. So, I mean, I think that separator, if you want to have the picture of everything together, maybe, I don't know, I wouldn't have those separators. And then if you've got a general note at the bottom, maybe you have to have a separator before the note. Make sense?
Okay.
Okay, assembly. Glue together. Oh my gosh. It'd be really nice if this was...
This is how these maker projects go.
Well, I understand that.
You mean you don't have a glue gun?
I believe that I actually do. Definitely have a soldering iron.
Yeah. Okay.
Somehow soldering irons got easier to use over the intervening 40-something years. They seem to be more difficult in the past. Anyway. Okay. What's this? Why are the connections? So that's now a schematic picture.
Yeah, because some of them are a mix of both mechanical and electrical.
Okay.
So we finished the mechanical physical part up and getting to the electronics.
What the heck? I mean, this is such a weird thing for us. Okay, so fine. Input, output, sampling period. Why doesn't that have units?
Yeah, because it's not systems models. We've never supported units there. So whenever we do use without units, it always means second.
All right. Well, hopefully we will be getting units in that. This is so frigging obscure. I mean, without wrapping it in association and saying what these things are. I mean, maybe I would get used to this, but by the time, what is this thing? By the time we've got 3 null lists.
Yeah, it just means it is.
What's that? I'm sorry?
It means it has no memory because those are the first 3 arguments. It just, the input is directly fed into the output.
Okay. Okay. So what is this? That the thing is connected to my computer on dev tty blah blah blah. Is that the idea?
Yes, that's how it's, the code is getting downloaded.
And this is some random option. This max value of 100 is a random option associated with port 11, which, by the way, notice here is not a string. For some reason, those are strings, but those aren't. So port 11 has that extra option associated with it. Is that correct?
Yeah, it's not port. It's the way we designed it. We want to say that because these registers, maximum value of the register is 256. We want to say that R100 should be. That's the maximum value that register will hold.
What does the 11 mean?
The 11 is pin 11 on the same as 0.
Whatever. I'm sorry. I'm not done. Okay. So that could be a 0 without a string, right?
Yes. Yeah.
Okay. Fine. Okay. So these things are going through an A to D into something that is, even though it says analog, it's really 256.
Yeah. So if when the max
these microcontrollers had built-in A to D and D to A converters,
right?
But they're not super high resolution, as you heard.
Yeah, I understand. They're 256, right? 8-bit, right? Okay. Okay. So, what the heck is that?
Yeah. So now we are getting into the device framework.
What is from ASCII?
Because it comes as character codes, and we want to get it back into.
What comes as character codes?
What's coming over the serial port? In a device frame. So after that,
unbelievably low level. Well, whatever. Okay.
So yeah. So after that device open, that is the device framework.
I see it. But the embed code that actually loaded the microcontroller embed.
So here, wait a minute. So here you see some use. What this device framework is going to do is pull data back in.
No, I get it. I get it. The microcontroller is running that code, and then the device framework is poking the thing.
Right.
Is the connector after the microcontroller is off and running its code.
That's right.
Yeah.
Okay. So one of the things that's an issue here is this embed code has a destination, which is that dev tty, right?
Which is the microcontroller connected on that.
I understand. I got it, right? The part that, okay, the thing I'm trying to understand is embed code, the function embed code, the ordinary function embed code doesn't have a target like that, so far as I remember. Do you know what I'm talking about?
The third
web.
I'm sorry?
For web browsers, right?
No, embed code is for, JavaScript Pro code.
See, it has a location.
Oh, it does. All right. Okay. I'm wrong. Okay. Terrific. Okay. All good. Okay. That's great. Okay. So that is saying send this microcontroller code. How does that send it to that location? Fine. It's a little weird that what comes back, I mean, this really, is that a representation of the device or is that a representation of the code? Do you understand my question?
It holds several things. It holds information about the device where the code was embedded. It also has information about the source code.
If I disconnect the device from the wire, from that, port of my computer, the device, and then I reuse this thing.
But the status is going to change. The green status is going to change away from green.
Okay, but there's nothing here that says this is connected to dev tty whatever. In that microcontroller code data, it doesn't say that.
Yeah, okay. So this is a fundamental difference between microcontroller embed code and the device framework. So microcontroller embed code does not maintain a connection after it has downloaded the code, whereas the device framework does. Microcontroller embed code just embeds the code and that's it.
Right. I mean, one of the things that sort of, okay, fair enough. So it's sending the embedded code to that destination where the microcontroller receives it. And the microcontroller, I don't know what bootloaders look like and things for microcontrollers, but if you just say, here's a bunch of bytes, and you send that to that port, the microcontroller just eats them in and says, great, that's going to be my code, or what?
Yeah, so the microcontroller gets this, and it is, so in this case, it configures its inputs and outputs as such, as analog, serial, and whatnot. And then anybody can now talk to it. And we have chosen the device framework to talk to it.
No, you're not understanding my point.
Okay.
When you say microcontroller embed code, right?
Yeah.
What it does are three things.
Okay.
It converts the expression to C code.
Yep.
The C code gets compiled with a tool chain provided by the device maker.
Yep.
They all provide their own tool chains.
Yep.
Okay, because it's not really quite C. Okay.
Yep.
That is then going to be loaded, and they're called programmers for. It's just what they're called. It's weird to me too. And that does exactly what Suba said. It configures it, downloads it.
Right, but if I run this again, okay, with a different configuration, that will simply blow away whatever was in that microcontroller before. Is that correct?
Yes.
So at any given time, only one program is loaded into each microcontroller. Is that correct?
Yes.
Wow.
There's no operating system.
No, I understand that, but it might be loaded in different places in memory, and there might be, like the computer I first used, always went to location 8181 in memory to start. But presumably these microcontrollers have some convention like that.
Yes, they do. Yeah. So the whole flash memory is where the program is. The whole thing is rewritten, and the pointer goes to the preset place and starts reading again.
Okay, fine. But there's only one program per microcontroller.
Yes.
Okay, great. Okay, so this will always blow away what was there before. Okay.
And all what you're looking now, this is all the device framework.
No, I can see that. Right. Motor data. So what are you going to do here? To task remove. So how did you get back? What is this doing? This is just giving me static data. Where is the where's the thing that actually runs the thing in the microcontroller?
So at a few inputs earlier, that's where we embedded the code to the microcontroller, and using the device framework, we got the data.
Where did you get the data? That's here?
Yeah. So I'm appending to RPM. So each time I get the RPM value, I'm storing it.
Okay. So RPML is that. Okay. Then what is this motor data?
So motor data is the duty cycle, RPM left, and RPM right.
But why aren't you showing that derived from anything? You're just typing this in here.
Because I'm getting so it's something duty cycle, RPM, and volts, but I'm getting it once, right?
No, I understand that, but in this example that you are showing here, you obviously got a value for duty cycle. It's 0 in this case, right? Show me where it actually is reading. So in this particular thing, you're saying session submit scheduled task, and that scheduled task. By the way, why is it in this funky font? Well, anyway, never mind that. But the scheduled task is running how often?
Is running every sampling period.
Okay, and the sampling period is SP, which was set to 1 or something, or whatever it was. Okay, fine, great. Okay, so that has succeeded. So if I look at RPML after that, I will have
the result of device read. And that's what I'm writing there in motor data.
But why are you just putting it in like copy paste? You don't want to do that. You want to show people how it runs.
To show how it runs, because this one, it's actually connected to the hardware.
I understand, but so it's a frozen case. You're not going to be able to show it in real time. I understand that, but just typing it in is not useful. you see what I'm saying? Nobody knows what this is at this point, right? So what you're showing here...
I think what we should do, so you can at least continue on, we could show, I agree with Stephen, we should show how it's derived from those things that are accumulated up there. But then we can still have, and we should use iconize and other things to not,
Okay.
Okay.
Right. So
then we can say sort of, here's a frozen, or we could say,
Yeah.
No, but that's what I do. I say that. See.
No. But what I want to know is, how did you get those numbers, right? Where did those numbers come from?
Yeah. Okay. So those numbers I got from device read.
I know you got those numbers from device read. You got those numbers in that line.
But the way we write
the
documentation, we should show how we get it.
Right? That's not saying how you got it. Those numbers are the list, RPM, something. Is that not correct?
Yeah.
Okay, so that's what you have to show. What you have to show is that the result here of the append to RPM, whatever, this motor data is probably a transpose of list RPM and something else. Is that correct?
Yeah, and each time the RPM is running, I'm also using a voltmeter and reading the voltage across the motor leads.
Okay, where's that being done?
That I'm doing physically with the physical setup. See, I'm just below those gauges. I explained that in that one sentence.
Oh. So, wow. So there's something that isn't computer achieved here. There's something that's achieved by you connecting something with a voltmeter.
Exactly, yeah.
I don't think it's a great example. I mean, can't you get something that reads? I mean, I understand why that voltage isn't read by the microcontroller. The microcontroller has an analog port. Just connect that to the, across those those leads, and the microcontroller should be able to read it. Am I making sense? Just like you can read the device read buffer. Now here, when you're doing a device read buffer, that's extremely ugly. And if we're really going to be using microcontrollers like this, shouldn't we provide code in the microcontroller embed code that sends stuff back in a form that isn't raw bytes with terminators? Do you get what I'm saying?
Yeah, so that is part of the device framework, and we have a prototype function for that. That will actually make all that code where I'm getting device read buffer and device write. It will make it more high level and more succinct.
Right, fine. But I mean, that's a question of the embed code could be sending stuff in the form that the device framework will just read it. Is that right? Or is that something different?
It is, yeah. So, yeah. It'll just, we can specify high level, get less. But Stephen, coming back to your question, doing it using some port or something, it's more complicated than this. Because we are reading very high voltages and the microcontroller cannot read that. See, I'm getting 6 volts and so on. Microcontroller will max out at 5 volts.
Then put a resistor there or something, or use a different motor. I mean, I don't know. Put a resistor, split the voltage. I mean, the idea that you're by hand reading a voltage here sort of spoils the point of this.
Okay, but for a first project, I don't really want to complicate the model that we use.
Fine.
No, but
whatever. So long as you explain what's going on and you can show how Stephen, the other numbers are derived, I'll be okay.
No, Stephen. So the reason I'm doing it like this here is because this is not the main thrust of the project. The project, this is a work for a big project, and what we're doing here is just getting the model of the motor, and that's not the end goal of this project. Once we get the model, we want to control the speed. When we are controlling the speed, that we do everything automated from it. So this is getting the model. Yeah. See, even here, when we are getting the model, we are getting data and fitting it and so on. But then the final end goal is to control the speed where we don't do these.
You could be using predict, couldn't you here? Do you really want nonlinear? Why don't you just use predict?
We need actual parameters. Otherwise, we don't get a model. We need an actual model that we can use.
Oh, I see what you're saying. You can't use a neural net because you have to download it to the microcontroller.
Well, but it also needs to fit in the systems framework. And it needs to be there, and it needs to be compilable to the microcontroller. It's,
Somebody on our live stream suggests not using a pen to, and I agree with them. As soon as we have the capability to have our new, gosh, I've forgotten what we're calling them now, our new expression object-like things, you should be able to use those instead.
Sure.
Okay. Wow, this is unbelievably super complicated.
Yeah, because
I guess this is what engineers do.
Yeah, this is a project because in the microcontroller embed code, then the scope we have simple examples, but this is like a full-fledged project.
I mean, this is big. You didn't really start from the simplest. I mean,
if this was being taught in some college class, how long would students take to do this project? Is this like one lab project, or is this like a bigger thing?
Depends on your previous training, but I've certainly done things like this in one lab.
Yeah.
Okay. Well, I'm trying to get my home HVAC system working, so I intend to use something like this. Although I was planning to have a computer in the loop.
Yeah. I mean, one reason you want to use microcontrollers is that they are dirt cheap.
Yeah, I understand. And they can be put in all kinds of places, and they probably have low power.
Exactly.
Wow. Well, that's cool. I mean, okay. So let's just review then. Oh, God. I mean, this stuff is so frigging low level.
Yeah, that's why we needed that function. Yeah.
What function? What function is it going to be?
It's yeah, we created it's called device submit, and then we can specify high level that we want it as a list or as these raw values and so on.
I don't think device submit is the right name. Device submit is an asynchronous type thing.
Yeah. Do you want to like look at it now? I can.
Sure. I mean, but this stuff. I don't understand why it would be there. I would have thought it would be in the microcontroller embed code function, would specify an input and output.
No.
Okay. But so the microcontroller embed code expects data in a certain format. On a serial port, it expects various kinds of bytes and so on. Is that right?
Yeah, just a minute. Let me. Okay, I just put it in the chat. Okay, so.
Oh, gosh. So I managed to hit the wrong thing here. Okay.
So this is something Igor and Ian, I came up with Igor and Ian.
Submits an asynchronous task. Okay.
They're just like session submit.
Yeah, right. Okay. That's what it should with a name like that. Why is it all caps for read?
Yeah, I do. Yeah, we can change it. So we're just saying read and write. They're like keywords.
Okay, so what this is doing, I don't understand this at all. I mean, what this should instead be, wow, I think this is kind of crazy, okay? So device read normally has a, let's look at what device read normally does. If I can get any of these things to work, the new version is not working there. Let's look at what device read does. So I see device read reads a parameter there. So that parameter can be real or integer. So why can device read not just have a thing that says read a list? Do you understand what I'm asking?
Yes. But yeah, so that doesn't work for device.
Why? Why? Why can't we make device read of RealList, for example, work?
Yeah, we can make that work. That would be a step up. Then we also device writing.
Well, sure, but same thing.
So that whole blob that you see where you say it's like too low level, that's the whole thing we are trying to...
I know that's what it's doing. I'm just saying, I don't think this is the right design. You don't need to do, I mean, there's a completely separate issue, which is whether it's asynchronous or not. But what I'm saying is, if you're doing it synchronously, the right way to do it is to just say device read, comma, RealList here or something, or whatever we call that type. You get what I'm saying?
Yeah, okay.
Right? You don't need this. This is an orthogonal issue. This whole question about asynchronicity is completely orthogonal to this. Am I making sense?
Okay. Yeah.
So, Roger, am I missing something here?
No, I think that there will be still. Go back and look. I'm not sure if you capture a lot of things. I'm not sure you capture everything.
No, right. So, device submit seems to have some other kinds of things that it's doing here. This is read data. I'm just completely confused here because these seem to be examples, not a specification. This is saying read the data, and then when you've read the data, well, I don't understand what this means. Read the raw values and assign it to you. Does that mean assign each raw value to that as it comes in, or what?
Yes, that's what that means. It's assigning, and then if you want to append.
I can see that. Yeah, I can see that. But I mean, I'm saying, okay, so list, what does that do? Because if you're assigning every raw value, then what does it mean when you say list there?
Yeah, so when you look at raw values, it involves like the delimiter byte, the start byte, and so on. This will put it into a more sanitized, just as a list.
Yeah, I understand, but you just told me that every single number it reads, it sets you to that number here, correct?
Yeah.
Whereas here, you're asking for a list. And so what I'm asking is, I'm assuming that that list is accumulating the successive values of you. Is that correct?
Only if you do append to.
Okay, but then what does it do in this case? Because it's an individual value here that you're saying set an individual value. What does the word list mean there?
It will just create a list of that individual value. So that list, will make sense.
Kind of random. It makes sense if you're reading multiple variables. Is that correct? Right. In this case here, it makes sense, right? If there are multiple U sub i's being read.
Yeah. Oh, yeah, that's right. You're right. Yeah. For the multiple U sub i's, the list will make sense. But to reach.
But in this case, raw values sounds like it's multiple values. So I don't quite understand that. Does that mean that across different things that are coming across the wire from the microcontroller, for example, one of them might be temperature, one of them might be humidity, one of them might be light level, that those three things will each successively be set. You will successively be set to those three if you say raw values, whereas in list, what you'll get is a list that contains temperature, humidity, light level. Is that right?
Yeah. Yes, it will. Yeah, raw values. Ask your question again, please.
Okay, listen this time, okay? So I'm saying if you've got, let's say, just two things, temperature and humidity, right? Okay. Those are coming across the wire from the microcontroller, right? Okay, what I understand that first thing to do is first it sets you to temperature, then it sets you to humidity. Is that correct?
No, the raw values, it will just set till the delimiter byte, whatever is coming, will be set to you.
Roger, help me out here.
Yeah, so that's the parsing that was going on there.
No, I understand, but do you understand what I was saying? I don't understand the difference between...
I don't think it ever does that, Stephen. I don't think it sort of crosses...
Okay, fine, but in that case, what's the difference between list and raw values?
I think that you get rid of all those delimited bytes.
The main thing is in list, you don't have to do from character array. Because what list does to raw values does from character.
Raw values is a completely different thing. Okay, all right, fine. So the raw values are the actual bytes. So it's an A to D that has 256 values for the that decodes into 256 values stored in a byte, and that byte might be the letter, the character ampersand or something.
Exactly.
That represent okay, but that is completely crazy. You should be using byte arrays for this. You should in no way be using characters. Am I making sense?
Okay. Yeah.
It has nothing to do with characters, right? Now, maybe you started developing this before, ages ago before we had byte arrays, but byte arrays are what you should be using for this.
Okay.
I agree.
Okay, now at least I understand what this is doing. Okay, now what I'm going to say is, I don't think this is the right way to do this, because I think this business here, for the submit functions, we have handler functions that do things typically.
Yeah.
Okay. So, but I think I'm understanding the flow here. So the flow is you define in microcontroller embed code, you are defining here this is the device type. This is the configuration of its input ports, its output ports.
Yes.
And you have various kinds of essentially macro things you can do there. Like, for example, you can say max value of whatever, which is a way of essentially adding a piece of code that you're not explicitly putting into the controller, but it is a convenience for example, stopping your microcontroller blowing up or whatever else it is. Is that correct?
Yes. Yeah.
Okay, so the additional items here. So at the raw level, the microcontroller has certain those pins. Certain things are connected to those pins. It might be an A to D. It might be something else, right?
Yeah.
Okay, and the signature of what's on the pins of a particular microcontroller is stored where?
It's not stored anywhere. The code is written to configure the microcontroller as such.
No, but wait a second. Isn't it the case that the hardware of the microcontroller has a pin number 7?
Yeah.
What does pin number 7 do? It has an A to D on the other side of it. Or is that not the case? Or can you configure a pin to be either analog or digital?
We can, yeah. So they're they're GPIO pins. They can configure sometimes for SPI, sometimes for analog.
Okay, fine.
The same pin.
I get it. Okay, so there is a signature of the microcontroller with its configuration, which includes pin 7 is a digital input, blah, blah, blah.
Yeah.
Right? Okay, now, in this controller thing here, wherever it is, if I wanted to, so the controller is mapping inputs to outputs in some way. So let's say that I wanted to take 2 inputs and I just want to make an adding machine. I want to take 2 inputs which are specified as bytes, and I want to produce an output which is the sum of those bytes.
Okay.
Right? How would I do that? What's the minimal controller that does that?
It's a transfer function model 1.1.
So when I represent this controller, the only way I can do it is through this essentially matrix technology of transfer functions. Is that correct?
Yes. Oh, I also allowed to just write mathematical expression, but that's like you can write U1, U2, U1 plus U2.
Well, so for what operations can you do that?
For things which don't have memory. Actually, if you look at microcontroller embed code in generalization and extension, I show that.
It's very limited set of operations, Stephen.
So there are no registers in these things, is that
yeah,
correct?
Yeah, so if we do it like this, then we cannot have any memory. We just take 2 inputs. The first output is the sum of the 2 inputs. The second output is...
Sorry, just my confusion here, but don't microcontrollers, they can have memory, right?
Yes, they do. But if you specify it as an expression, we don't have a mechanism to give memory except in those system models as of now.
But I see. But we could, in principle, imagine a module where the variable X is something which is stored in the register in the microcontroller and so on, right?
Yes. So it's something we have to do in the Wolfram language, something beyond the system models, where we say that this is a register.
Okay, but system models, when you say system model, you're talking about one of these state-space models, for example, whereas in system modeler, when we talk about system model, blah, 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 that is not something which can necessarily be reduced to one of these state-space models. Is that true?
No, no, they can't, not in general. However, you can, first of all, they're often very big. The ones when you model with high fidelity.
Sure.
They're way beyond.
Yeah, and they won't fit in a typical microcontroller.
No, not even close. On the other hand, what you often are interested in, why you build these big models is for everything around it. Not only, let's say in this case, the motor. The motor is one component in a big system.
Yes.
And you want to see how that, fits into that big system. That's why they're complicated. And we can derive linearized models, for instance, for a subset of those system models.
Yeah, I get it, which you can then represent in these state-space model formulas.
Right, and then you can design controllers, signal processing algorithms based on that, which we have workflows.
But so in modern times, if I'm understanding, people are trying to build sort of generalized microcontrollers that have neural nets inside them. Is that true?
Yes, but a little bit bigger machines than 8-bit.
I think there are people who are trying to do 8-bit neural nets, but that's a different story probably.
Yeah, but all of those, most of them come with, what you do today, if you're going to run neural nets, is that they often have a functional block, and you have to be able to convert your neural net model into a language that's understood by that block. So I think that's very interesting for our neural nets to understand what are the standard formats that can actually go into these embedded neural nets that are coming up left and right in automotive and other places. So I think that's on us to sort of kind of fit into that.
Well, I think that MXNet is going to be able to target a bunch of those things.
I'm guessing too. But it would be nice for us to check out how far that's come.
Right. Okay, so look, in terms of the details of this design, my tendency is, this thing where we have deeply nested lists, I have to say, I think we should be using rules and maybe some associations in these things rather than, in fact,
the rules get rid of one level of list, but you still need a list of outputs there or inputs.
No, that's fine. That's not a problem. So the other question is whether we should be using the typed wrapper of the compiler for these things. Is that crazy?
Yeah. No, it's not crazy. In fact, that's one of the things that come up later if you look here in the review.
Okay. Well, external type signature?
Yeah. So this was done prior to the compiler existing.
Right.
Okay.
But yeah, so using the typed wrapper.
These are very simple types, Stephen. They're not parameterized types. It's nothing.
Well, I know, but that's okay. It's just like we have types like integer 8 and so on.
Right. They're at that level.
Right.
That very level.
But now, where you're looking at this serial, what does that mean? Go ahead.
It means two outputs, both are serial. Because there are two, the system has two outputs.
Oh, I see. Okay, when you say serial, that, like analog means it's just going to be a certain level.
Yeah.
Serial means that it's what? It's got an initiation byte, a termination byte, and so on, or what?
Yeah.
So where do you configure? Like the serial thing could have all kinds of random junk, like parity and all kinds of stuff.
Yeah.
How do you specify that?
So there are default values. And then if you look at that data object that is returned and ask for the serial property, it will tell you what values it used. And if you want, we can give an option there. We can individually specify the parity, the stop byte, the start byte, and so on.
Okay.
That's in the details of that argument, serial argument.
Yeah, I get it. Okay, I'm understanding. Boy, this is really low level. Much lower level than I had even.
It is, Stephen.
But it's okay. It's okay.
These things, so what would you do if you didn't use a microcontroller to get at a similar price point? You might try to build an FPGA or something.
Yeah.
But it's cheaper if you can use, off the shelf.
How much do microcontrollers cost?
They can be 50 cents. Yeah. And so on your drone, you know, the motor controllers on that drone, they're microcontrollers.
Yeah. How many microcontrollers are there in a typical car or something?
Probably on the order of 50 or so.
Okay. And each of those things, so for us, the only thing we're representing is, you know, these system models, state-space models.
Right.
But I'm sure that most microcontrollers, somebody wrote custom C code and just...
Yeah, that's how they go. Okay, so if you go to one of these sites, the people that sell either microcontrollers or microboards, how do they specify projects? Most about that project is how to write the C code.
I see.
Okay, but we've trivialized that step.
At least in the case where it can be represented with a state-space model.
That's correct.
And can you characterize what can be represented by a state-space model?
It's, I mean, so, I mean, our state-space model are a little funky because they are, so everything sort of, the most things that you want to do with control and signal processing is that, first of all. So that's a big class of things.
Yes.
State-space models can be very advanced. They don't have to be linear, you know, and that general, the nonlinear state-space model is not linear, as you probably guessed.
From its name, yes.
Right.
I mean, so fundamentally what's happening is it's like a big function with some amount of memory.
Right.
And what's happening is, you know, inputs are coming in and basically, I mean, it's very similar in concept to a modern neural net. Inputs are coming in, you know, maybe it's a recurrent network and it's remembering some stuff. Maybe it's not. Maybe it's just, you know, goes straight through. And then fundamentally stuff is coming out that is, you know, the outputs from the microcontroller. But this is kind of a, I mean,
Sure. No, yeah. I mean, the idea for, you know, I mean, that idea for neural net comes from here. So it's...
Yes, I know. I mean, the history was right. People were doing neural nets before they were even doing well. They were about the same time that early... So in fact, I'm just about to go to something where it's supposed to be a rerun of the Macy conferences on cybernetics from 1946 to 1953. I just got on my desk here the proceedings of all those conferences, which I haven't opened yet because I just arrived.
Yeah. So the thing that took off first from cybernetics was control, and Norbert Wiener, who wrote Cybernetics,
the book at least, yes, and
yes,
yeah,
he worked at the Radar Lab in Boston, right?
Indeed, right,
Rad Lab, and the thing that he came up with was he was very proud of was a bomb site. Right, of how to do that. They ended up not using his, but the ideas that he came up with was later refined to become usable. It's called a Wiener filter.
Right. Okay. But so that's the.
But that's how he got sort of the insights. It's like, oh my God, this occurs everywhere. He wrote the book.
You know, I just opened this proceedings at a random page, and the topic, the running head at the top of the page is communication between sane and insane.
Well, I mean, but they were discovering this thing that the human body regulates pH level in blood, and that's like a controller. And yes. They discovered this, like it seems to occur everywhere.
Right.
So.
Right. Well, in any case, the fair enough. So, okay. So the point of what we're doing here is to automate. So how?
But the point I wanted to say too was. Control was the thing that took off and became very industrial and practical and very advanced, and you have it all around you. You know, first.
When people can program this stuff, usually, then are they doing it from symbolic state space models, or are they doing it, you know, line by line in C code?
Line by line in C code.
It's a mix of both. Yeah, there are the experts do it line by line in C code.
And so the C code we generate, is it decently optimal? Or optimal enough, at least.
I mean, I think it's optimal enough. I mean, there's not much
the work done during the time that the microcontroller has to react. It's probably
right. Exactly. So it's hard real time. You know, the physics doesn't wait for you, unfortunately. But
so what is the minimal? So you have a variety of microcontrollers that you're supporting here. Does it matter which one you use? I mean, do they all have different characteristics, or is it like general purpose CPUs mostly?
Yeah, they have different memory. So if the controller and the features are more involved, we cannot use a smaller microcontroller. We need more memory.
Okay, fine. But I mean, other than the memory parameter, is it the case that it's just up to us to compile it for the correct instruction set and so on? Or is it that different microcontrollers have different, I mean, if it was general purpose computers, it doesn't matter if you're using a Beagle Bone or a Raspberry Pi.
I think they have different amounts of numbers of analog A to D converters.
Okay, fine.
Different.
And there are other factors.
Yeah, go ahead.
Other factors too. Some of them consume lower power than the others. So
I get it. But I mean, fundamentally
from our perspective, it's just different instruction sets.
So you connect the thing to your computer, it pushes the code into flash memory, then you disconnect it, and, as soon as you put it on a battery, it will start, running its program. Is that correct?
Yes.
And if you want to monitor it, that's for debugging purposes. That's when the device framework comes in. So we can, read
Right,
stuff.
I understand. So that's the way that we can peek and poke at this microcontroller.
Yes.
I get it. Well, this is nice, but I mean, I think the only thing I would have to say is I think we should clean up the device, the way the device framework interacts with this. We should, what you're telling me is for most of these microcontroller operations, in the end, it's going to be...
I am in so much trouble.
You're late. Okay.
I am horrible. Okay.
Well, I should go too, but all right. Well, nice stuff. I think we're going to need to look at this yet again, preferably in not too long, so that we haven't completely forgotten what's going on here. But there's a bit of syntactic cleanup, but otherwise, cool.
Okay. So I'll wait for the next meeting before I go with any design change at this point, right?
That is correct. Yes.
Yeah.
Okay. Sounds good. Good work. Okay.
All right.
See ya.
Thank you.
Bye.